Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to Math Solver 1117. Today we are going to solve class 11 Maths model paper by Federal Board for 2025 exams. In this video we will solve section B short questions. Each question is done step by step. If you are new, subscribe Math Solver 1117 and also hit the bell icon to get notification for all upcoming videos. Now we will start from question number 1. Now question number 1 is, if the angle between two vectors A is 2i minus 3j plus 4k and B is I plus 2j plus 2k is theta, then find the values of cos theta and sin theta. Now in this question, we will use two formulas. First of all, we know that A dot B dot product of this is equal to the magnitude of A, magnitude of B cos theta. This is the first formula we will use in this question. And another important formula, this is used for finding cos theta. Now we have to also find the sin theta. So sin theta is equal to the square root of 1 minus cos square theta. So we will use these two formula. First of all, we will take the dot product of A and B. So A dot B is equal to the, first of all we will write the vector 1, that is 2 minus 3 and 4, and other is 1, 2 and 2. Now the dot product of this will be equal to 2 into 2 is 2, then 3 into 2 is minus 6 plus 8. So 8 minus 6 is 2 and 2 plus 2 is 4. Now we will take the magnitude of A, it's mean 2 square plus minus 3 square plus 4 square. So the magnitude is equal to the 4 plus 9 plus 16, it's mean this will be equal to 16 plus 4 is 20, 20 plus 9 is 29. Now we will find the magnitude of B, which will be equal to the 1 square plus 2 square plus 2 square. So this will be equal to 1 plus 4 plus 4. So 4 plus 4 is 8, 8 plus 1 is 9. So square root of 9 is equal to the square root of 3 square. So square is cancelled by this square root and we have just 3. Now we will put the values in this formula, that cos of theta will be equal to the A dot B divided by the magnitude of A and the magnitude of B. So A dot B is equal to the 4 and 3 square root 29. So this is the value of A dot B cos of theta. Now you can easily find the value of sin theta, which is equal to square root of 1 minus cos square theta. So sin theta is equal to the square root 1 minus cos square, means cos theta is equal to the 4 by 3 square root 29. So this will be equal to 16 by 9 into 29. This is the value of cos square theta. So 16 by 29 into 9 will be 216. Now by solving this we will get square root 261 minus 16. So we have sin theta is equal to the, so by taking LCM, 261 minus 16 is equal to the 245 by 261. Now by taking the square root of this will become, this will become 7 square root 5 by 269 in the form of square will be 3 square root 29. So this is the value of sin theta. Now we will solve question number 2. Now the question number 2 is prove that n minus 1 r plus n minus 1 r minus 1 is equal to n r. We will solve this question in very easy and simple way by binomial coefficient method. So we know that NCR, which can be write as NR is equal to the n factorial over r factorial n minus r factorial. So we will use this concept in this question. First of all, we will take the left hand side, that is equal to n minus 1 CR, which will be equal to the n minus 1 factorial by r factorial and n minus 1 minus r factorial. And the other term is n minus 1 C of r minus 1 can be write as n minus 1 factorial by r minus 1 factorial, then n minus 1 minus r plus 1 factorial, and this will become n minus 1 factorial divided by r minus 1 factorial, and minus 1 and plus 1 is cancelled out and we have n minus r factorial. Now we will add 1 and 2 because in the left hand side we have the addition of these two. So by combining these two we can write this as before adding we can first simplify these two such that make the denominator is r factorial n minus r. For this purpose we will multiply this by n minus r by n minus r. So this term will be equal to the n minus 1 factorial and then we have now question number 2 is prove that n minus 1 r plus n minus 1 by r minus 1 is equal to the nr. We will solve this by binomial coefficient such that in the left hand side we have n minus 1 factorial by r factorial into n minus 1 minus r factorial and plus n minus 1 factorial, then r minus 1 factorial and n minus 1 minus r plus 1 factorial. Now by solving this we will get n minus 1 factorial by r factorial into n minus 1 minus r factorial plus n minus 1 factorial r minus 1 factorial and minus 1 and plus 1 are cancelled out, so n minus r factorial. Now we have to prove this equal to the nr means NCR, which is equal to n factorial over r factorial into n minus r factorial. So in the denominator we have common factor, that is r factorial and n minus r factorial. So we will make this such that such that we will multiply first by n minus r. So you will write this as n minus 1 factorial into n minus r and r factorial into n minus 1 minus r factorial into n minus r. So this term will be equal to the n minus 1 factorial by into n minus r, and n minus r and n minus 1 minus r will become r factorial into n minus r factorial, and here you will make n minus 1 factorial and multiply this by r and r. So this will become r minus 1 factorial and n minus r factorial. So you will have r into n minus 1 factorial by r factorial and n minus r factorial. Now you can take n minus 1 factorial as common. So remaining is n minus r by r factorial n minus r factorial plus r factorial r by n r factorial into n minus r factorial. Now you will solve this here. Take n minus 1 factorial as common, and by taking LCM you will get r factorial n minus r factorial. So this is equal to n minus r and plus r. So n minus r and plus r will be cancel out. So you will have n minus 1 factorial into r by into n minus 1 factorial into n, because minus r and plus r are cancel out. So you will have just n by r factorial into n minus r factorial. So this term can be write as n into n minus 1 factorial means n factorial by r factorial n minus r factorial, and which is equal to the right hand side. So we have proved this question in very easy and simple steps. Just we have make the denominator, that is n factorial n minus r factorial into r factorial. For this purpose we will solve this. Now question number 3 is find the maximum and minimum value of the function y, which is equal to 1 by 5 plus 6 sine 2x plus 3. We will solve this question. We will find the range of the denominator and then solve the question. So we know that the value of the sine function lies between the range of the sine function from minus 1 to plus 1, means sine x is between minus 1 and plus 1. So how we will solve this? First of all, we will make this the range as minus 1 is less than or equal to sine 2 of x plus 3. Now you will multiply this function by 6. You have to make 5 plus 6 sine 2x plus 3. So when you multiply this by 6, minus 6 is less than or equal to sine 6 sine 2x plus 3 is less than or equal to 6. Now you will add 5. So 5 minus 6 is less than or equal to 6 sine 2x plus 3 less than or equal to 5 minus 6. 5 plus 6. So 5 minus 6 is minus 1. Minus 1 is less than or equal to 5 plus 6 sine 2x plus 3 less than or equal to 11. So this give you that minimum value is -1 and the maximum value of this is 11. So now you find the range of y. So range of y you will be find by, so you see in the question that y and x are inversely. So when x is maximum, y is minimum, and when y is minimum, x is maximum. So we will find y maximum such that this will be equal to maximum when sine 2x plus 3 is equal to 0. So 1 over 5 plus 6 into 0, you will say that sine 2x plus 3 is equal to the 0. So y maximum is equal to 1 over 5. And now y minimum when sine 2x plus 3 is maximum. So you will write 5 plus 6. It's mean that when sine of 2x plus 3 is equal to the plus 1. So you will say y minimum is equal to the 1 over 11. So this is the final result of this question. Because x and y are inversely proportional, so that's why we will say when x is minimum, y is maximum, and when x is maximum, y is minimum. Now we will solve question number 4. Now question number 4 is in HP if A3 is equal to 1 by 11 and A16 is equal to 1 by 63, then find the value of A1, D and A20. Now let's suppose A3 is equal to 1 over 11 and in arithmetic progression A3 which is equal to 1 by A3 and 1 by A3 means 1 by 11. So this is equal to 11. And A16 which is equal to 1 by 63 and in arithmetic progression A16 is equal to 1 by 63. So this is equal to 63. Now you will write the formula of arithmetic progression. A3 is equal to A1 plus n minus 1 means 2D and A16 is equal to A1 plus n minus 1 means 15D. Now you will subtract both these. So put the value of A3 that is equal to the 11 and value of A16 that is equal to the 63. So by subtraction you will get A1 and minus A1 are cancel out. 2D minus 15D is minus 13D and 63 minus 11 is minus 52. So D is equal to 52 by 13 which is equal to 4. Now you have find out the value of D. Now put this value in any one equation. So A1 plus 2D which is equal to 11. So A1 is equal to the 11 minus 2D means 11 minus 2 into D 4. So this will become 11 minus 8 which is equal to 3. So A1 is equal to the 3. Now you will find the value of A20 which is equal to A1 plus 19D. A1 is 3 plus 19 into D is 4. So 3 plus 76 which is equal to 79. So now the value of A1 is 1 by A1 means 1 by 3 and a20 is equal to 1 by a20, which is equal to 1 by 79, and d remains same for both, that is equal to 4. So this is the solution of question number 4. Now question number 5 is, if force is equal to 3 minus 2 and 5, act on at point P, that is 3 minus 4 and 2. Find moment of the force about origin and the point 1 minus 1 and minus 1. So you will solve this question in very easy and simple way. You have to find the moment. So the formula of moment is equal to the m, which is equal to r cross f. So you will take the cross product, which means that r is equal to this vector. So first of all you will write I, j and k. Then write the 3 minus 4 and 2. And then f3 minus 2 and 5. Now you will expand this with respect to r1. So I is equal to minus 20 plus 4, and then minus j is equal to the 15 minus 6, and then plus k is equal to the minus 6 plus 12. Now what will be the value of this is equal to the minus 16i minus 9j plus 6k. So this is the moment about origin. Now you will find the value of this at point 1 minus 1 and 1. So before finding this point, you know that r is a position vector from 1, minus 1 and minus 1. Since this rp is already given, so you will write that moment about 1, minus 1 and minus 1 is find out by 1 minus 1 and minus 1 to point P, that is 3 minus 4 and 2. So you will find the value of r here, that is 1 minus 3 minus 1 and minus 4 plus 1 and 2 plus 1. So r is equal to 3 minus 1 is 2, minus 4 plus 1 is minus 3, 2 plus 1 is 3. So these are the vectors. Now you will again find out the moment about this point, which is equal to r cross f. So ijk remains same and r will be changed. So r is equal to the 2 minus 3 and 3. Now the last value is 3 minus 2 and 5. Now you will expand this with respect to row 1. So your answer will be equal to the I into minus 15. So minus 15, then plus 6 minus j will be 2 into 5 is 10, 10 minus 9 is minus 1, 10 minus 9 will become plus 1, then k will be 2 into minus 2 is minus 4, and then 3 into 3 is 9, minus minus will become plus. So your final result will be equal to minus 9i minus j, 9 minus 4 is plus 5k. So this is the moment about the point that is given 1 minus 1 and minus 1. Now we will solve the next question, that is question number 6. Now question number 6 is, if A, B and C are the angles of a triangle such that A plus B plus C is equal to the pi, then prove that tan of A plus tan of B plus tan of C is equal to the product of tan A, tan B and tan C. Now we will solve this question in very easy and simple steps. First of all, you will consider the given situation, that is A plus B plus C is equal to the pi. Now you will apply tan upon this, then A plus B is equal to the pi minus C. So tan of A plus B is equal to the tan of pi minus C. So here you apply the formula of tan A plus B, that is tan of A plus tan of B, and divided by 1 minus tan of A tan of B. So here you will get minus tan of C. Now by cross multiplying you will get tan of A plus tan of B is equal to the tan of minus tan of C minus minus plus tan of A tan of B and then tan of C. So you will get the required result, that is tan of A plus tan of B plus tan of C is equal to the tan of A tan of B and tan of C. So this is the final result. Now we will solve question number 7. Now question number 7 is, prove that sine of 5x minus sine of 3x by cos of 5x plus 2 cos 4x plus cos 3x is equal to tan x by 2. So you will solve this question. First of all, apply two different formulas, that are, if sine of A minus sine of B, the formula is 2 cos A plus B divided by 2 and sine A minus B divided by 2. This is the first formula. And another formula that will be used is cos A plus cos B, which is equal to the 2 cos A plus B by 2 and cos of A minus B by 2. So you will apply these formula in this and get the final answer. So in the left hand side you will apply, so 2 cos 5x plus 3x divided by 2 and sine 5x minus 3x divided by 2. And in the denominator you will apply the formula on cos 5x and cos 3x. So 2 cos of 5x plus 3x divided by 2 and cos 5x minus 3x divided by 2. And then remaining is plus 2 cos 4x. Now this will become, by simplifying this, you will get 2 cos 5 plus 3 is 8, 8 divided by 2 is 4x, 5 minus 3 is 2, 2 divided by 2 is 1, so sine of x. And here you have 2 cos 4x, cos of x plus 2 cos 4x. So you can take common 2 cos 4x. So you have 2 cos 4x sine of x by 2 cos 4 of x into cos of x plus 1. So 2 cos 4x is cancelled out by 2 cos 4x and you have just sine of x and cos of x plus 1. Now you can apply the double angle formula for tangent, that is equal to the tan x by 2, which is equal to sine of x by cos of x plus 1. So this is the double angle formula for tangent, and this is the proof of your right hand side. Now we will solve. Next question is, draw the graph of the function y is equal to 2 cos x such that x is from minus pi to plus pi. So first of all we will draw the table and then draw the graph. So take different values of x and get different values of y. So first of all you will put x is equal to minus pi. So 2 into cos minus pi will become minus 2. And then put x is equal to the minus 3 pi by 4. So y will be equal to minus 1.41. Then you put x is equal to the minus pi by 2. You will get value of y will be equal to 0. Then you put x is equal to 0. You will get value of y is equal to 2. Now you will put positive values pi by 2, then you will get again 0, then put plus 3 pi by 2, you will get the value is plus 1.41, then put positive pi and value is plus 2. Now we will plot the graph according to these points. So let's suppose this is the y-axis and this is the x-axis, and the value of x are, this is 0, 1, 2, 3 and 4, and this is minus 1, minus 2, minus 3 and minus 4, and this is 0 0.5, 1.5, 2.5 and like this 1.0, 1.5 and then 2.0, and here minus 0.5, minus 1.0, minus 1.5 and then minus 2.0. Now the shape of the graph will be like the curve starting from minus 3 to between this and maximum value. Then the shape of the graph is like this. Now we will solve question number 9. Question number 9 is find rank of the matrix. We will find the rank of this matrix. For this purpose, first of all, change the R1 into R12 such that the leading coefficient is 1. So 1, 2, minus 1, 2, 5, 7, minus 3, minus 6 and 3. You have changed R2 to R1. Now in the next step, we will make this 2 and minus 3 equal to 0. For this purpose, you will write 1, 2, minus 1 and you will do R2 minus 2R1 and R3 plus 3R1. So 2 minus 2 is 0. 5 minus 4 is 1 and 7 minus 2, 7 minus 2 minus minus plus, so 7 plus 2 is 9. Now minus 3 plus 3 is 0, minus 6 and plus 6 is 0, 3 and minus 3 is 0. Now 2 rows are non-zero, so rank is equal to the 2. Rank of this matrix will be equal to 2. Now we will solve question number 10. Now question number 10 is find roots of the cubic polynomial, that is 3x cube minus 5x square minus 11x minus 3. First of all, you will put x is equal to -1. Then you get 3 into -1 cube minus 5 into -1 square minus 11 into -1 minus 3. So -1 cube is -1 into 3 is -3 minus 5 and minus plus 11 and minus 3. So this is equal to -8 plus 8, which is equal to the 0. So -1 is the root of this. Now by synthetic division we will solve this further. 3 minus 5 minus 11 and minus 3. Divide this by -1. So 3 into -1 is -3, and then -3 minus 5 is -8. -8 into -1 is +8, and this is -3. -3 into -3 is -1 is +3. So we will write this as equal to the, in the form of quadratic equation, 3x square minus 8x minus 3 is equal to 0. Now we will find the roots of 9 such that when they are subtracted give 8. So 3x square minus 9x plus x minus 3 is equal to 0. Take 3x as common, remaining is x minus 3, and plus 1 is common, remaining is x minus 3. So roots are 3x plus 1, x minus 3, both are equal to 0. So x is equal to 3 or x is equal to -1/3. So the roots are -1, 3 and -1/3. So this is the answer of this question. Now we will solve question number 11. Now question is, find the value of r such that P56 r plus 6 ratio P54 r plus 3 is equal to 30800 ratio dot 1. So we will write this as 56 factorial and divided by this by 56 minus r plus 6 factorial, and this is equal to 56 factorial by 50 minus r factorial, and write the other one as 54 factorial, 54 minus r plus 3 factorial. So this is 54 factorial over 51 minus r factorial. Now write this in this ratio form. It will become 56 factorial by 50 minus r factorial multiply by 51 minus r factorial and divided by 54 factorial, and this is equal to the 30800. Now in the next step we will have 56 factorial can be write as 56 multiply 55 multiply 54 factorial, and 51 minus r can be write as 51 minus r into 50 minus r factorial, and here we have 54 factorial multiply 50 minus r factorial. So 50 minus r factorial is cancelled out by 50 minus r, and 54 factorial is cancelled out. We have 56 multiply 55 is equal to the 30800, and multiply this 51 minus r. So 51 minus r is also on the left hand side. So this will become 51 minus r is equal to 30800, and divide this by 56 multiply 55. So 51 minus r is equal to the 10. So r will be equal to 10 minus 51 is minus 41. Minus minus cancel out, and the value of r is equal to the 41. Now we will solve the last question. Now question number 12 is prove by mathematical induction that 7 raised to power 2n plus 7 is divisible by 8 for all positive integers. So we will solve this. First of all, put n is equal to 1. So you will get 7 raised to power 2 plus 7, which is equal to 49 plus 7, which is equal to the 56. So 56 is divisible by 8, which is equal to 7. So it is true for n is equal to 1. Now by mathematical induction, we will suppose it is true for n is equal to k. 7 raised to power 2k plus 7 is true. We will prove this for n is equal to k plus 1. We will use mathematical induction to prove this. So 7 raised to power 2 into k plus 1 plus 7, which is equal to 7 raised to power 2k plus 2 plus 7. Now we say that it is true for n is equal to k, 7 raised to power 2k plus 7. Let's suppose we give this a name. 7 raised to power 2k plus 7 is equal to the 8m. Because it is divisible by 8, so we will suppose this equal to 8m. Now write this 7 raised to power 2 and 7 raised to power 2k plus 7. Now 7 square is 49. So this is equal to 49 dot 7 raised to power 2k plus 7. Now you can write this as 7 raised to power 2k is equal to the 8m minus 7. So you will put the value of 7 2k in this. So 49 into 8m minus 7, then plus 7. So this is equal to the 392m minus 343 plus 7. So this is equal to the 393 minus 336. 393m and minus 336, and both are divisible by 8. So we say that p into k plus 1 is true. So this is the solution of all short questions. In the video description, you will find the solution of other short questions and the long question and all MCQs of this paper. Best of luck for your exams. Stay tuned. Allah Hafiz.